Good morning, students. Myself, Shankar from EC Department, Chevrolet Engineering College. Today, we are going to discuss about the Z transform. In the yesterday's class, also we completed some part of the introduction part of the Z transformation, and find the Z transformation of a power n mu of n. If x of n is equal to a power n mu of n, what is the Z transformation? The Z transformation we got is x of z is equal to 1 by 1 minus a z inverse. This is the first example. Coming to the second example is also the same. That is, the Z transformation is same, but the input value x of n you can take as x of n is equal to minus a power n mu of minus n minus 1. These two are very important, my friends. Coming to the second example. And now coming to the second example here, it's very, very important. These two are very important because for both the functions, the Z transform is same. 1 by 1 minus a z inverse only. The difference is the region of convergence. Previously, the region of convergence is outside the circle, the unit circle, and here inside the unit circle. Inside the unit circle. Now, you see, the given signal is minus a power n minus a power n mu of minus n minus 1. Minus n mu of minus n minus 1. So, in the definition, x of z is equal to the sum of n is equal to minus infinite to infinite x of n z power minus n. The definition of Z transformation. How to find out the Z transformation of the signal x of n is equal to sum of n is equal to minus infinite to infinite. The given x of n is minus a power n of minus n minus 1 z power minus n. Okay, this is a given signal. Now we can change these limitations. Change the limitations mu of minus n minus 1. Mu of minus n minus 1 minus 2 is minus means the negative real axis. So let us see. The mu of n graphical representation starts from the 0 is a 1, 1 is a 1, 2 is also 1, and 3 is also 1. Okay, what is the mu of minus n? Minus means is a folded at the 0. There is no any change in the 0, the value is 1, and now 1 will get in the minus 1. Is also magnitude 1, minus 2 is now is a 1, minus 3 is a 1, and 1, 2, 3 is a zeros. Mu of minus n. And this mu of minus n, now I am subtracting mu of minus 1. Subtracting the mu of minus 1. So folded function, or mu of, take the minus as a common here. Take the minus as a common, mu of minus of n plus 1. Plus means is advanced function. But you have to do for the folded function. One sample is moves towards the left hand side. One sample moves towards the left hand side. Got it, my dear students? If any can add for the folded function, it can move towards the right hand side. But the subtraction in the folded function means the left hand side. Okay, minus means the delay. But mu of n is there, you can shift towards the right side. Mu of n is there, you can shift towards the left side plus 1. But the folded function, reverse operation. Or you can use this, the mu of minus of n plus 1. Plus Plus you can remember it is an advanced function towards the left side. But for the folded function, okay, folded function is one sample towards the left side. So 0 is now the 0, and start from the -1 is a 1, -2 is a 1, and -3 is a 1, and so on. So from minus infinite to, and here also the so on. So mu of -n-1 value is a 1 with a range of n is equal to from minus infinite to -1. Remember my students here, -1. Okay, don't write it as a 0 because it's shifted towards the left side with one sample. Minus a power n, and this value is a 1 after changing these limitations, z power minus n. Okay, now I am changing the sum of minus is already there, here the minus, n is equal to, you can add 1 to infinite, or the infinite to 1 is both are the same. So -1 to minus infinite. A z power -1 whole power n. So now you can remember here, my students, if you change these negative signs in the summation, you can keep the negative power. Got it, my students? Is equal to minus sum of n is equal to 1 to infinite. Changing both the negatives is positive, and keep here z power -1 whole power minus n. It's a very important one. Now, I'm doing this one. You see, when it is in the form of a power n only, the sum of n is equal to n1, n2, a power n is equal to a power n1 minus a power n2 plus 1 by 1 minus a, and n2 is always greater than n1, and a is less than 1. We know this condition is a very important formula. It is a power n only, the positive value. So I'm changing this x of z is equal to minus, already we have sum of n is equal to 1 to infinite, including that it is a minus inside. So a power -1 and the z whole power n. So whenever if I am taking the minus inside, the minus a power -1, minus into minus is a plus, and it is positive. Now it looks like sum of n is equal to n1 to n2, a power n. What is the n1 now? n1 is a 1. So a power -1 into z whole power 1 minus, and a power -1 z whole power infinite plus 1, because it is a upper limit is infinite only, by 1 minus a inverse z. And already we have the minus is there in front of that minus. So anything power 1, this value will get the same. Infinite, anything power infinite is a 0. Okay, minus of, what is the value here? A power -1 into z whole divided by 1 minus a inverse z. According to this condition here, a is less than 1. What is the a here? A inverse z. I'm taking the a inverse z is less than 1. Z by a is less than 1, and z is less than a. What is ROC now? Z is less than a. Remember that one. And simplify this. Take the a inverse z is a common. Minus a inverse z is same. Take the common. A inverse Z whole divided by 1 by A inverse Z minus 1. Got it, my dear students? I'm taking the denominator as A inverse Z as a common. A inverse Z as a common. 1 by A inverse Z minus 1. So A inverse Z and A inverse Z is a get cancel. And it is equal to 1 by A inverse Z. 1 by A inverse Z means you can bring that in the numerator. A inverse in the numerator is a Z is in between the numerator is a Z inverse minus 1. Already in front there is a minus is there. Multiply this minus 1 by 1 minus A Z inverse. 1 by 1 minus A Z inverse. So the same response we'll get for the minus A power n mu of minus n minus 1 also. Got it, my dear students? The same thing for A power n mu of n, the Z transformation you can apply. It is the same 1 by A Z inverse. And for the same minus A power n mu of minus n minus 1 also, the Z transformation will get the same thing, 1 by 1 minus A Z inverse. But ROC is a difference. What is ROC for this one? ROC is Z is greater than A. Remember this one. Okay, ROC for A power n mu of A. And Z is less than A. ROC for minus A power n mu of minus n minus 1. Okay, to find the inverse Z transformation for the given 1 by 1 minus A Z inverse, it depends upon the ROC, the inverse Z transformation is changes. If ROC is greater than means, you can write as A power n mu of n. If ROC is less than A, you can write as minus A power n mu of minus n minus 1. Got it, my dear students? So see here the same thing, they also did x of Z is equal to minus sum of n is equal to minus infinite A power n mu of minus n minus 1 Z power minus. And taking the limitations here from minus infinite to minus 1, replacing the mu of minus n minus 1 is a 1. So E power n Z power minus n. And minus V already there. I'm changing these signs as positive values and change the powers as a positive to negative and negative to positive. So here the positive is there, write it as a negative. And here the negative is there and you can write as a positive. So why they wrote this a 1 minus means 1 minus, because it starts from the 1. N is equal to 1. Okay. When you can substitute n is equal to 0 here, n is equal to 0 also, A power 0 and A power Z power 0. Anything power 0 is a value is a 1. You can subtract from 1 minus my students. Or otherwise, directly using this one, you can substitute in the whatever the formula we already know. 1 by 1 minus A. After simplification, you will get 1 by 1 minus A Z inverse. With the ROC being the set Z is such that Z is less than A. Note that the Z transform is same as that of example 1. The only difference is the ROC. In fact, example 2 is just a left-sided version of example 1. Right-sided means mu of n. Left-sided means mu of minus n and minus 1. Why it is not minus 1? You can ask the question like this also. But actually, mu of n starts from the 0. Okay, is a positive, including the 0 also it is a positive. So I'm not taking the 0 because it's a discrete time function. You can take from minus 1, minus 2 and minus 3 minus 2. But in the continuous time function, there is a in between minus 1 and the 0 is also the values is there. So for that condition, they are taking there, it is a mu of n and the mu of minus n for continuous time function. And coming to the discrete time function, left sided means mu of minus n minus 1. Right sided means mu of n. Left sided version of example 1. What it is? Example 2. Got it, my dear students? It's a very, very important examples, a power n mu of n and minus a power n mu of minus n minus 1. Okay. Next one. And here the whole 0 is there. So first of all, I shown outside the circle, the shaded area here in the gray color, outside the circle A. Now, and this the shaded area is inside, there is a gray color because it is Z is greater than, Z is not the greater than, less than. Z is less than, A is ROC inside the circle. Stable system. Previously, it is outside the circle. The shaded area is outside the circle. Unstable system greater than A. Got it? ROC. The pole 0 plot of ROC of example 2. Okay. So coming to the third example here. Third example, my dear students. Consider the signal. Consider the signal x of n is equal to 7 1 by 3 whole power n mu of n minus 6 1 by 2 whole power n mu of n. Okay. 7 is a constant, 6 is a constant. Now it is in the form of a power n mu of n and a power n mu of n. Directly can write. So what is a power n mu of n? Z transformation is, what is the Z transformation? 1 by 1 minus a Z inverse. What is the a here? 1 by 3. What is the a here? 1 by 3. So Z transformation of the given signal x of Z is equal to, using this a power n mu of n. I'm directly writing here the 7 is a constant. 1 by 3 means 1 by 1 minus 1 by 3 Z inverse. Okay, this a power n mu of n minus 6 is a constant, multiplication factor, a power n mu of n. What is the a here? 1 by 2. So 1 minus 1 by 2 Z power minus 1. Okay, Z power minus 1. Now we can simplify this. X of Z is equal to, X of Z is equal to, you can write as 3Z minus 1. So Z power minus 1 means it's also denominator only. Okay, or directly here there is a 7 into 1 by 1 minus 3Z inverse minus 6 into 1 by 1 minus 2Z inverse. The final answer it is. Got it, my dear students? Or you can simplify the 7 by 1 minus 1 by 3Z minus 6 by 1 minus 1 by 2Z. Okay, is equal to, you can bring that in the numerator, 7 3 is 21Z whole divided by, take the LCM here, 3Z minus 1 minus 6 2 is 12Z whole divided by 2Z minus 1. Still you can go for the simplification by taking the LCM of 3Z minus 1, 2Z minus 1 and multiply and simplify. Okay, or directly you can keep like this only simply. X of Z is equal to 7 into 1 by 1 minus 1 by 3Z inverse minus 6 into 1 by 1 minus 1 by 2 Z inverse. Got it? So now the ROC. So what is the ROC here? Previously see the given functions, these also the a power n and it is also a power n. Z is greater than of this function, z is greater than 1 by 3. And for this function, the z is greater than 1 by 2. Here the minus is there. Okay. Now the ROC you can see for x of z converge, both sums in x of z must converge. So we need both z is greater than 1 by 2 and z is greater than 1 by 3 and 1 by 2. Thus, the ROC is a set of z such that z is greater than 1 by 2. Why is this z is greater than 1 by 2? It is greater than the 1 by 3 and greater than the 1 by 2. So 1 by 3 and the 1 by 2. 1 by 2 means is a 0.5. 1 by 3 means is around third one. So 1/3 and here the half one. So this value is greater than. And from 1 by 3 is less than the value compared to the 1 by 2. So thus the ROC is the set of z such that z is greater than 1 by 2. Z is greater than 1 by 2 only. The pole and the zero, full zero plot of ROC of the example. So I will show here. The ROC we can take here. Z is, if I am writing it as z is 1 by 3 here. 1 by 3. So 1 by 3 means a point 0.3 around. And this one is a 0.5333 something. Z is greater than outside the circle here. Outside the circle, the first one. Z is greater than 1 by 3. Okay. Now, I'm checking the another circle here. This is another circle. What is ROC here? The ROC now 1 by 2. Means outside the circle is greater than outside the circle. So outside the circle. So what is a common ROC now? Common ROC. If it is greater than 1 by 3, there is no any overlapping here of both the ranges. But in the when the greater than 1 by 2, there is a overlapping occurs for the greater than 1 by 3 and the greater than 1 by 2. Okay. So what is ROC? Thus the ROC is a set of, see the shaded area here. But I am not taking the 1 by 3. So outside the 1 by 2 only. Okay. Thus ROC is a set of z such that z is greater than 1 by 2 because there is a overlapping. But z is greater than 1 by 3 and z is greater than 1 by 2. And we take the from z is greater than the 1 by 3 here. But there is no any overlapping of z is greater than 1 by 2. So combine ROC you have to write because the given function is the additive combination of the two functions. Understood, my dear students? Okay. Now, the properties of ROC. The properties of Z transformation is also there. Now the properties of ROC. Remember and listen carefully, my dear students. Because in the part A, you have to write the part A, there is some questions, and the part B, you have to write some questions. Definitely, these are the properties of ROC of Z transformation and the properties of ROC of a Laplace transformation. This is a 3D question. Directly, you have to write some points. You'll get the 3 or 4 marks. It's very important. No need to prove the ROCs when they're given in the part A. If suppose they're given in the part B means you have to prove the ROCs also, the region of convergence. So first property saying that the ROC is a ring or disk. Read it circle. ROC is a ring or disk in the Z plane, center at the origin. See, is a Z plane, we can take That R is the radius. We can draw a radius with a center with origin, the unit circle. Okay, the ROC is a ring or a disc in the Z plane, center at the origin. It is a 1 or 1 by 2, it depends upon the value. So actually we are taking always the default, the unit circle only. Okay, and property 2 saying that discrete time Fourier transform of x of n, discrete time Fourier transform of x of n exists if and only if ROC includes the unit circle. ROC includes the unit circle. When R is equal to 1 only, then the transform becomes a Fourier transform. That too, discrete time Fourier transform. Discrete time Fourier transform of x of n exists if and only if the ROC includes the unit circle. By the definition, ROC is a set of z such that x of z converges. Discrete time Fourier transform is the z transform evaluated on the unit circle. Why I am saying this, already we seen the x of r into z power, not the z, e power j omega is equal to the sum of n is equal to minus infinite to infinite, x of n, z is nothing but r into e power j omega whole power minus n. When r is equal to 1, nothing but the unit circle is a unit circle, or we can call it as a disk also. Okay, it becomes of x of e power j omega is equal to sum of n is equal to minus infinite to infinite, x of n e power minus j omega is the definition of Fourier transformation for discrete function, sum of. So we can call it as a discrete time Fourier transformation is evaluated on the unit circle. Therefore, the ROC includes the unit circle, then the x of z converges for any value of z on the unit circle, that is discrete time Fourier transform converges. Got it, my dear students? This is the second property of ROC. And third property, the ROC contains no poles. ROC is the region of convergence. Region of convergence is greater than the R and the less than the R and equal to R. The region of convergence contains no poles. Fourth property saying that if x of t is a finite impulse response, remember my dear students, FIR filter we can call it as, then ROC is entire Z plane. Entire Z plane means from below the minus infinite and the below the plus infinite. This total shaded area, entire the Z plane. When in the finite impulse response, FIR, if x of n is a finite impulse response, then the ROC is entire Z plane. Not inside, outside like this we are saying, entire Z plane. Below the minus infinite and below the plus infinite and below the plus j infinite and minus j infinite. It is not equal to, always in the boundary, inside the boundary. The fourth property saying that. What is the fifth property? If x of n is a right-sided sequence, right-sided means outside the circle. I already told the S plane and the Z plane. Right side is outside, left side is the inside, and on the imaginary on the circle. The mapping here. The fifth property saying the same thing. If x of n is a right-sided sequence, then the ROC extends outward from the outermost pole. Outward from the outermost pole, right-sided. Okay. If x of n is a left-sided sequence, left-sided sequence. See here, this one the left-sided. This is a left-sided. This one is a right-sided. Right-sided means outside of the outer word from the outermost pole. If x of n is a left-sided means stable system. The ROC extends inward from the innermost pole. Inward is the inward here. Right, students, inward of the Z plane. Okay. The left-sided sequence, if x of n is a left-sided sequence, then the ROC extends inward from the innermost pole. If x of n is a right-sided sequence, the ROC is outward from the outermost pole. Okay. If x of n is a finite impulse response, then the ROC is entire Z plane. Entire Z plane. These are the fourth, fifth, and the sixth properties. First property is saying that the ROC is a ring or a disc in the Z plane, is centered at the origin. And the second property is saying that discrete time Fourier transform of x of n exists when it is exits on the unit circle, because r is equal to 1. The z is equal to r into e power j omega. R is a magnitude and omega is a phase angle. Then r is equal to 1, nothing but the unit circle. The discrete time Fourier transform of x of n exists if and only if the ROC includes the unit circle. And third property is saying that ROC contains no poles. The region of convergence, outside, inside, and the on. And fourth property is saying that the entire Z plane is ROC, means x of n is a finite impulse response. And the ROC is only the outward from the outermost pole, means the x of n is a right-sided sequence. And the sixth property is saying that ROC extends inward from the innermost pole, means the left-sided sequence. Got it, my dear students? Remember these all the 6 properties. Definitely will get in the part A. They ask with the 4 marks. You can write any of these 4. And some more is also there, the properties. 7th property saying here, if x of z is rational, x of z is equal to, the numerator is a of s, a of z, and denominator we have considered as a b of z, where a of z and the b of z are polynomials, quadratic expressions. And if x of n is a right-sided sequence, then the ROC is a region outside the outermost pole. If x of n is the right-sided, even in the given function x of z is a rational in the form of a of z and the b of z, where a of z and the b of z are polynomials. And if x of n is a right-sided, then the ROC is the region outside the outermost pole. Let us say here the x of z is equal to a of z by b of z. A of z as a sum of a suffix k z power k, and bz can represent it as a pi poles 1 minus p suffix k z power minus 1, p suffix k power minus 1, and z whole power k. And simplify this, we'll get z is greater than the p1, and the other is the right side because x of n is a right-sided. 1 by 1 minus 1 by 3 z inverse, 1 by 1 minus 1 by 2 z inverse. For example, if it is a function, we have not understood this one, function, the z is greater than the 1 by 2 because in the two poles, 1 by 3 and the 1 by 2. See the causal and stable and the causal and unstable and the non-causal. I already explained this one. It's the 10th property. And each of the term in the partial fraction has an ROC being a set of z such that z is greater than the pi. Why it is a PI means the 1 by 2 only. See the PI here, CI by the PI poles, that is always greater than the PI, not the PC suffix I. Each term in the partial fraction has an ROC being a set of Z such that Z is greater than the PI because X of n is a right-sided. In order to have X of Z is convergent, the ROC must be the intersection of all individual ROCs. Therefore, ROC is taken outside the outermost pole. Outside the outermost pole means 1 by 3 is less than the 1 by 2. So you can take the outermost pole only, the 1 by 2. Then the ROC is the region the Z is greater than the 1 by 2. Got it, my dear students? Okay. If any functions like this, the rational function, in this rational function, the B of S having the poles, in that pole also Z is greater than the PI. That PI is, you can take the ROC is which is outermost pole. And ninth property is saying that a discrete time linear time invariant system is stable if and only if the ROC of H of Z includes a unit circle. H of Z includes the unit circle, means inside the system. The system is stable if and only if H of n is absolutely summable, if and only if the discrete time Fourier transform of H of n exists. Consequently, the property 2, ROC of H of Z must include the unit circle. Stable system. So I already told causal and stable. Causal and stable means, see here the poles that are present inside the circle, stable system. See, unstable means any one pole that is outside the circle. So I am taking the unit circle here, the pole is outside the circle here, unstable system. And non-causal and stable. Non-causal and stable means one pole is also in the outside the circle. See, this of the circle is there. The poles that are present inside this circle, causal and stable. The poles that are present inside the circle, and if any one pole is outside the circle, is a non-causal and stable. And see here, inside and the outside is also there, unstable system, the region of convergence. So in between the shaded area here, see, the shaded area is outside the circle, and shaded area is outside the circle ROC, and shaded area is in between the circles. In between the circle. A causal discrete time linear time invariant system is stable. A causal discrete time linear time invariant system is stable if and only if all of its poles are inside the unit circle. All of its poles. When it is a stable, my dear students, all of its poles are inside the unit circle. Inside the unit circle, then we can call it as a stable system. The causal and non-causal. If any is outside the circle means unstable.